Science Squad! Welcome back to our channel. Today, we're diving into some seriously cool physics, the laws of motion, conservation of mass, conservation of energy, and the magic of collisions. Trust me, by the end of this vlog, you'll be seeing the world in equations. Let's go!
Let's kick things off with the Newton's three laws of motion. These laws explain how and why things move or don't.
An object at rest stays at rest and an object in motion stays in motion, unless acted on by an unbalanced force. See, this ball, it won't move unless I push it, and once it's moving, it only stops because of friction.
Second law, law of acceleration. The greater the force, the greater the acceleration. But mass also matters. Example, hold two balls, one heavy and one light. Push both with the same force.
Watch this, the lighter the ball goes faster. That's Newton's second law in action. Force equals mass times acceleration.
Now, let us proceed to conservation of mass. Now, onto the law of conservation. This law says matter cannot be created or destroyed in a chemical reaction. It just changes form.
Example, you mix vinegar and baking soda in a sealed bag. The bag inflates.
Even though it looks like stuff in disappearing or transforming, the total mass stays the same. The gas just moves from liquid to air.
Law of conservation of energy says energy cannot be created or destroyed, only converted. Example, show someone at the top of the slide, then sliding down.
At the top, it's all potential energy. As you slide, it becomes kinetic energy. No energy is lost. It's just, it changes form.
Let's talk collisions. There are three types: elastic, inelastic, and perfectly inelastic.
Hey guys, have you ever wondered how different types of collisions work?
Yeah, I've been curious about that.
An elastic collision is where both momentum and kinetic energy are conserved. For example, if you bounce off two rubber balls off of each other, they'll keep moving without losing energy.
So in an elastic collision, the objects don't stick together or deform?
Exactly. Now, in an elastic collision, momentum is conserved but kinetic energy is not. The objects might stick together or get deformed. Like if you drop a piece of clay on the floor, it will flatten out.
And finally, there are perfectly inelastic collisions where the objects stick together after the collision. Like if you mash two pieces of Play-Doh together, they become one lump.
That's right. In perfectly inelastic collision, the objects do not separate, and all their kinetic energy is converted into other forms of energy.
So to sum up, the main difference is how kinetic energy behaves. In an elastic collision, it conserves. In an elastic collision, it's not. And in perfectly inelastic collision, it's completely converted.
Thanks for explaining that. It really helps to understand the differences.
Absolutely. Now, let's watch some videos to see those principles in action.
Sounds like a plan. I'm curious to see some real-world examples.
Me too. This conversation has made me even more interested in physics. So there you have it. The universe is basically just following a giant rulebook written by physics.
It's always fascinating to learn more about the world around us.
Me too. This conversation has made me even more interested in physics. So there you have it. The universe is basically just following a giant rulebook written by physics.
If you learned something cool today, hit that like button. Drop your favorite example in the comment section below. Subscribe for more real-world science.